They are one of the objects with the highest magnetic fields in the universe. They also have very high density, and they are characterized by energetic recurring events. But what are magnetars? Where do they come from? And how can we study such distant and powerful objects? So, what are magnetars?
Well, magnetars are a subclass of neutron stars. They are the strongest magnet in the universe, hence the name magnetars. Just for you to imagine, a teaspoon of the material from magnetars would weigh as much as mountains. So they are very dense material with ultra high magnetic field.
And what makes them different from common pulsars?
They both are cousins in neutron star family, but they glow or they have different radiation for different reasons. Let's start from pulsars. Think of them as pulsars are lighthouses, but powered by the rotation. However, magnetars are flash lobes powered by decaying of their magnetic field. Another way also to think of the differences between pulsars and magnetars are pulsars are steady clocks, especially the millisecond pulsars, which are also subclass of neutron stars. However, magnetars are unpredictable firecracks, since they have what we call it flaring activities that make them unpredictable in terms of the transient phenomena. Additionally, also magnetars rotate much more slower compared to the pulsars. So in pulsars, yes, they are different classes. Magnetars considered to be like slow. They rotate from 1 to 10 seconds. However, in other subclass of neutron stars such as millisecond pulsars, they can rotate or spin very fast in comparison with magnetars.
So, are there any theories regarding their birth?
Yeah, so as I mentioned, magnetars are subclass of neutron stars, so that means they follow the same path of formation of neutron stars. So neutron stars are the leftover of the massive stars. So magnetars, they form from core collapse supernovae from massive progenitor with rapidly rotating proto-neutron star, where their dynamo action builds up a very strong internal magnetic field. Also observationally, several magnetars associated with the young supernova, or you could also find them in massive stellar clusters, which support the scenario that they are associated with young neutron stars that born in recent massive star deaths.
So, is it true that magnetars can be observed only when they are in an outburst? And what is this outburst phase?
Yes, so that's true. So outbursts are very energetic events. It's part of the what you call flaring events or flaring activities from magnetars, and these range of phenomena include outbursts and burst as well as giant flaring. So for the outburst, the way you think of it, if you can imagine, this is the neutron stars or the magnetars. So the magnetic lines in the magnetosphere of the star get twisted, so they put stress on the solid crust at the outer layer of the magnetar, of course, the crust break. Hence we call it starquake. So a massive flash of gamma rays is released to the outer space. So these flarings can release more energy in tenths of a second than our sun in almost thousands or hundreds of years. So it's a massive amount of energy being released during these flaring activities, or the so-called outbursts. Hence, since we will receive this large amount of energy, it's the best way to receive them or to detect them. Hence, yeah, those events help us to detect those magnetar sources.
And in what energy band can we observe the outburst or flaring activity?
So the best to observe them through the X-ray, because they have strong X-ray luminosities. However, several also number of magnetars sources have been observed through the radio observations as well.
And in the gamma ray band, can we observe something?
Yes, they are also, you can also, so some of those events that I just mentioned as flaring event, you can, they can extend their energy up to the gamma ray.
Okay.
Yeah.
And there have been another type of phenomenon recently in the radio astronomy community that had a lot of interest among the people, and they are the so-called fast radio bursts. Is there a connection between fast radio bursts and magnetars?
Yes, that's true. So fast radio bursts, from the name, they are signals very fast, in order of milliseconds, so they are very fast. Detected mainly in radio, hence the name fast radio burst. And long time researchers were trying to understand the source of these radio and fast radio signals. Until recently, there is a source. It's a magnetar that produce signals that coincide with this effect. So, and this is one of my actually favorite source. It's called the galactic magnetar. It's known as galactic magnetar SGR 1935. In 2020, for first time, researchers found out there is a coincides signals from this magnetar in X-ray and radio fast radio burst signals. So they both coming from the same direction in the sky, and for the first time they being able to link the fast radio burst signals with magnetars. So for now, among many sources, magnetars are one of the leading theory that to be the source of this fast radio burst.
Thank you.